Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're going to continue our discussion on circles. And what we're going to do in this video is look at a question where you're given an equation of a circle, but not in standard form, and you have to convert it to standard form. And from that, you can then extract the center point or the vertex and the radius. And then using that information, you can graph it. If you want to follow along with the procedures for this and prefer to read along with it in written form, you can find step-by-step procedures in my book, Algebra in Words 2, which you can find on Amazon, and the link to that is in the description box below. What we're going to look at starts on page 125 of this book. So let's get started. Now, the process that we're going to use for this is pretty easy, and it actually draws on a method called the complete the square method that you probably visited a few lessons back, and I did a video on a few videos back. So in short, this is what we're going to do, and there's not really much to say about it, so let's get started. But as a quick overview, we're going to apply the complete the square method to the x's and the y's of this equation. So what we want to do first is to make sure that the x's are together and the y's are together, and then we're going to split it up so that there's room, and I'll show you what I mean. So looking at these terms, we already have the x's first, and the x squared first, and then the x term first, and then the y squared term, and then the y term, and then a constant on the right. So watch how I split this up and leave some spaces. So I'm going to write x squared minus 4x plus, and I'm going to leave space. And under that, I'm going to call that the new c of x. So I wrote a little subscript x. That's the new c for x. All right, and now the y terms. Plus y squared plus 4x. This should be y. And then a space for the new c for y. Okay, and now equals. And rewrite the constant -3. And now we're also going to write a space for the new c of x and the new c of y on the right as well. Because if you remember, when you complete the square, whatever you add to the left, you have to also add to the right to maintain the equality on both sides of the equal sign. Okay, and now we're going to do the complete the square method. First for the x's, then for the y. So let's focus on x squared minus 4x. And if we had to complete the square, if you remember how to do that, what we need to do is use the equation for the new c, which is b over 2 squared. B over 2 squared. And in this case, b is -4. So write that over 2. And -4 over 2 is -2. And -2 squared is 4. So 4 is the new c. And that goes, and just so that we can tell the difference of the numbers, let me change colors, and we're going to put 4 here. And coincidentally, when we're looking at the y's, this b is also, well actually in this case, this b is positive 4y. It's going to turn out to be the same, but let's go through the steps anyway. So we're going to have b over 2 squared, and we're going to put positive 4 in for b, and 4 over 2 is 2. and 2 squared is 4. So coincidentally, the new c for x and y are the same here, but in other cases they could be different, and that's normal. And remember, what we do to the left, do to the right. So we added 4 for the new c of x here, and we add 4 here. And we added 4 for the new c of y here, so we add 4 for the new c of y on the right as well. Okay, so let me erase some of the work. So we can continue. And now that we have, if you notice that what we just created was a perfect square trinomial for the x's and a perfect square trinomials for the y's. Now we're going to factor those perfect square trinomials each into binomials squared, and on the right we're going to just add the numbers. So let's start with the x's. And focusing just on these, we can now factor that into the binomial squared, x squared minus 2. Or I should say x minus 2 squared, and plus, and now let's factor the perfect square trinomial for the y's into what will become x plus 2 squared. Sorry, y plus 2 squared. If you're wondering why is this minus, it's because this is minus. And if you're wondering why is this plus 2, it's because this was plus for b, for the y's. Alright? And now on the right, we have negative 3 plus 4 plus 4. So if you think of 8 minus 3, we get 5. And now, if you look at this form, it should look familiar. Doesn't it resemble this? Yes. Now, this is in the standard form equation for a circle. So with that little transformative method of completing the square for the x's and the y's, we now have our circle in standard form. And now we can extract the vertex and the radius. So let's start with the center. And since this is x minus 2, then h will be positive 2. And since this is y plus 2, k is going to be negative 2. And what about the radius? Now this is interesting, and try not to fall into this trap. 5 is not a perfect square. So, but what you have to remember is we still have to take the square root of it. So long story short, to find the radius r, we would take the square root of the 5. And the radius we would call square root of 5. And that's going to come out to be just a little over 2 if you calculate it on the calculator. But if you leave it as square root of 5, that's fine. You might in this case want to calculate it because since we are going to draw the graph, you probably want a number that that's usable to apply to the graph when drawing it in terms of units. So anyway, let's graph. Okay, we have the graph. We know the center is going to be 2, negative 2. So let's come over 2 and go down 2 and draw a dot. That's going to be our center or our vertex. Okay? And now, since we have our radius of square root of 5, and if we estimate that, I don't know the exact number, but I know it's going to be a little bit more than 4, somewhere between square root of 4 and square root of 9. So let's call it 2.2. All right. And starting at the center, which would be here, let's go up 2 units and just a little more than 2 units. So up 2 and a little more, that's right there. Back to the center and go right 2 and just a little past that, so here. And then back to the center and then left 2, 1, 2, and a little past that, here. And then back to the center and down 2. 1, 2, and a little past that, maybe here. So now we have 4 dots representing the radius from the center in the 4 directions. And let's just connect those with rounded curves. Again, not the best sketch, but it does the job. And basically, that's done. That's all we need to do. A quick note, this is the square root of 5, and if you're wondering why didn't I do plus or minus the square root of 5, well, in real space we only have the positive form of that, so that's why we kept the positive form of that. But to reiterate what we did here, we started with an equation of a circle that was not in standard form. But then we did a conversion to make it into standard form by clustering the x's together and the y's together. And then to both the x's and the y's separately, we applied the complete the square method. I like to leave a space for the new c for the x and the y on both sides. We complete the square, and then we complete the square using the mini formula b over 2 squared. We complete the square. That creates a perfect square trinomial for both the x's and the y's. Then we factor the perfect square trinomials into binomials squared, and that's what puts it into this form, which is the standard form of a circle. Whatever numbers we had on the right, we combine them, and remember, that makes r squared, not just r. So when you need to find r, take the square root of that number, no matter what it is. And once you have the vertex and the radius, graph them accordingly, and that's pretty much it. That's pretty much circles in a nutshell. So anyway, I hope you found this helpful. Thanks for watching, and see you in the next video.